Hello students, let's continue with exercise 1.2 of number systems. So we completed the first question in the previous class. So let's proceed further. We need to state whether square roots of all positive integers whether square roots of all positive integers are irrational. If not, I missed an R over here. If not, give example of square root of a number that is an irrational number. That is a rational number. So what do you think? Now positive integers, let's take 1, 2, 3, 4 and so on. Okay. So if you need to find the square root of 1, it is going to be 1, right? Square root of, this is not irrational. Square root of 2 is approximately equal to 1.414 and so on. This is irrational, right? For root 3 also, since it is a prime number, remember we learned that square roots of prime numbers are irrational. So this is also irrational. Its value is approximately equal to 1.732 and non-repeating decimal numbers. What about root 4? Square root of 4 is 2, which is rational. There are other numbers also. For example, 9. The square root of 9 is 3, right? Square root of 9 is going to give me 3, which is again a rational number. So not all numbers are going to be irrational. That is, not all square roots of positive integers are irrational. Okay, and an example is 4, the root of which is root 2, the square of which is 2. So square root of 4 is 2. So my answer, no, because an example is square root of 4, an example root 4 is 2, which is a rational number. Right? Let's proceed to the third question. Show how root 5 can be represented on a number line. So with this also we are going to draw a number line because we need to represent root 5. Okay. So let us go ahead and draw the number line first. Okay, so I have drawn my number line x dash o x. Okay, each of this, the space between 0 and -1 and -2 is 1 and so on. Similarly here it is 1 unit between 0 and 1, 1 and 2, 2 and 3. Okay, let me just confirm whether I have done it right. Hang on. Yes, it's right. So now I need to draw root 5 on the number line. I need to represent it. So again I am going to use my Pythagoras theorem. So let's say I have a triangle A, B and C, right, where B is my right angle. I need to plot root 5. So let's say my hypotenuse is root 5. So root 5 is what? It is nothing but under root of 4 plus 1, right, which is nothing but under root of 2 square plus 1 square, right, where this is going to be one of my side, let's say AB square, and this is going to be BC square. Therefore my AB becomes 2 and BC becomes 1, right. So I'm going to use the same strategy to plot root 5 on my number line. Okay, So initially I am going to take 2 over here. Okay, I mark this as point A. Now with A as my point, I am going to place my protractor over here at point A and I am going to mark 90 degrees, right? And I am going to draw this perpendicular from this point that I just marked as 90 degrees to point A. Right? So see, I have drawn a perpendicular to my number line at point A. Right? So I have found, now this length O to A is 2 units. So we have marked, let's say, this point AB. Now we need to mark the other point BC, which is 1 unit. So I am going to take 1 unit. Now 0 to 1 is 1 unit, so I am taking 1 unit as 0 to 1. Okay. With A as my center, I cut an arc of 1 unit on this perpendicular line, right? And now I am going to join points O to, let's say, B. Okay. So now I have drawn my right angle triangle OAB, which has a right angle at point A. Okay, this is the right angle. So obviously this length is 1 unit, AB is 1 unit and OA is 2 units, right? Therefore, according to the Pythagoras theorem, this is the hypotenuse, which is root of 5. Agreed? Now with O as my center and OB as my radius, I am going to cut an arc here, right? So this length from O to C, okay, this point here is root 5. Why root 5? Because O to B is my radius. I use the same length to cut an arc on my number line, right? So even this length is root 5. So this point here becomes root 5. Okay, so this was a very shortcut method to find root 5. Just in case, let me just erase this side, then I will explain you further. So if you have any positive integer, let's say m, okay, and you need to find the square root of m. To find square root of m, we can always do that once we have found or located under root of m minus 1 on the number line. Right? Now how? Let's say we have done this in the solved examples. So let's say this is my number line, right? I take my center as O, x dash and x, points of equal units here. This is 1, 2, 3. This is minus 1, minus 2, minus 3, right? So how did I draw root 2? How did I locate root 2? This was 1. This length OA from 0 to 1, 0 to A was 1. I drew a perpendicular here. Then I cut an arc of length 1, right? So this length became my hypotenuse, which was root 2, right? OB. OB became root 2. Note that this line OB is root 2 and not this point over here on the number line, okay? Now I have wanted to draw root 3. So I already had root 2 over here. So this length is root 2, right? Now I wanted to, first of all, this would be my root 2. Taking O as the center and OB as my radius, I cut root 2 over here. right? Now if I wanted to draw root 3, this was already root 2, right? OB was root 2. I draw a perpendicular, I extend this line and I draw a perpendicular on this line OB, right? This is the perpendicular. I cut 1 unit here and then I join this line. This also becomes a right angle triangle. This length is 1. So this length O2C becomes root of 3, right? By using Pythagoras theorem, which is under root 2 square plus 1 square, which is under root of 2 plus 1, which is under root of 3. So this length here OC is root of 3, correct? Now if I want to draw root of 4, again what I am going to do is I am going to extend this line. I am going to draw a perpendicular. I will take 1 unit here and I will join this line, right? So this length was 1 unit. This is root 3. Obviously this becomes under root of root 3, root of root 3 the whole square plus 1 square, which is under root of root 3 plus 1, which is under root of 4, right? So this length here is root 4. Now with O as my center and D as my radius, OD as my radius, this is D, this point is D. With O as my center and OD as my radius, I will just cut an arc here, right? This will be, right? So did you notice that when I plotted root 2, I was able to plot root 3. Similarly, when I found root 3 or located root 3, I was able to locate root 4. Root 3 was supposed say here. With O as my center and OC as my radius, I cut an arc here, right? So whenever you have a positive integer m, okay, and you need to find root m, it is very simple to locate that on the number line once you have found root m minus 1 on your number line, okay? So with this we have learned how to locate irrational numbers on the number line. We will continue with the rest of the chapter in the forthcoming lectures. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.